Hello! This is my very first attempt at making a tutorial, so apologies in advance if it's a little flawed. The goal here is to walk you through every little step in scripting a simple mobile game. I don't want to get bogged down in developing all the art assets for this project in advance, so I've taken the liberty of pre-building them for you. If you're watching this, you've already downloaded those assets and you've set them up in your project folder as directed. So I'm kind of winging it a little bit, but you're going to get a player character, which is a little red dog, or maybe it's a fox or a poorly drawn chipmunk or something, and he's going to go around looking to collect as many coins as possible before the time runs out and he's forced to retire. It's a metaphor for life, I guess. Let's get started. This game uses portrait mode, so you're going to need to adjust the size of the game window. Click on the project menu and select project settings. You're going to look for the display or window section and set the width to 480 and the height to 720. While we're here, you're going to set the stretch mode to 2D and the aspect to keep. This is going to ensure that if the user resizes the game window, everything will scale appropriately and it's not going to become stretched or deformed. And if you like, you can also uncheck the box for resizable, which will prevent resizing altogether, but for this demo it doesn't really matter. Okay, so vector math is really an essential tool in game development, and it involves a lot of linear algebra. I'm not going to go into it right now. We may have a micro lesson on it later on. But when working in 2 dimensions, you're going to be using Cartesian coordinates to identify locations in space. A particular position in 2D space is therefore written as a pair of values, such as 4, 3, representing its position along the x and y axes. Any position in the 2D plane can be described this way. In 2D space, Godot follows the common computer graphics practice of orienting the x-axis to the right and the y-axis down. You can also think of the position 4, 3 as an offset from the 0, 0 point, or the origin. Imagine an arrow that points from the origin to that point. That arrow is called a vector. I'm hoping that you guys are familiar with vectors, but if you're not, it represents a great deal of useful information about the point's location, its length, its angle from the x-axis. I'm really hoping that I get around to actually diagramming all this out, or it's going to be really awkward. Altogether, this is called a position vector, so it describes a position in space. Vectors can also represent movement, acceleration, or any other quantity in physics that has an x and a y component to it. In Godot, vectors are described as vector 2 for 2D or vector 3 for 3D vectors. They're really widely used, and you're going to be dealing a lot with them over the course of this class. So the first thing we're going to make is a scene that defines the player. One of the benefits of creating a separate player scene is you can test it independently even before you've created anything else in your game. This separation of game objects is going to become more and more helpful as your projects grow in size and in complexity. Keeping individual game objects separate from each other and in separate scenes makes it a little bit easier to troubleshoot, makes it easier to modify, makes it easier to just replace assets completely without affecting other parts of the game. It also means that your player is reusable. You can take your player and use him in entirely different games, and he'll work the exact same way until you reconfigure him. So the player scene is going to include your character animations, how your character responds to user input, and detecting collisions. So we're going to start by clicking the Add New Node button and selecting Area 2D. Then you're going to click on it and rename it Player. You're going to click Scene, Save Scene, and you're going to save this scene, and it's going to be called Player. We're going to add more functionality to this scene by adding children to this node. But before we do that, it's really a good idea to make sure you don't accidentally move or resize any of those children by clicking on them. So select the player node and then click that icon next to the lock, and it makes sure that the object's children are not accidentally selectable. Alright, so we're going to add children to this area 2D. We're going to start by making an animated sprite. This will be what the character actually looks like. And you'll notice that there's nothing there, and there's a little alert thing. We actually have to populate the sprites. So we go and add them as frames, and we're going to start by adding the run sprites, and then the hurt sprites, and then the idle sprites. And we're going to name each set of animations here. So we're doing the run ones first, and the idle ones, and the sprites for when our little dog gets injured. And again, all those assets are already waiting for you. Now, that's the complete cycle of sprites that you'll see for each of those statuses. We can set the speed at which they'll play. So right now they'll play 5 frames in every second. We're going to increase that to 8 for all of these. So they play a little bit faster, a little bit smoother. Looking good. And now we can see what this actually looks like. We're going to click on the player, click on the animated sprite specifically, and then we're going to hit where it says playing. You're going to hit that on, and you can watch our character running. If you want to change the animations, you're going to have to go back to the animated sprite and then go from animation run to animation idle and animation hurt. So you can cycle through your animations and see what they actually look like in action by playing them. Looking good. Pretty cool. So when using Area 2D or one of the other collision objects in Godot, it's really important to have a shape defined, or it can't detect the collisions. A collision shape defines the region that the object occupies, and it's used to detect overlaps or collisions. Shapes are defined by a shape 2D, and it can be a rectangle, a circle, a specific polygon. Sky's the limit. So for convenience, when you need to add a shape to an area or a physics body, you can add a collision shape 2D as a child to that node. You then select the type of shape you want, and you can edit its size in the editor. So we're going to do that right now. So we go player, add child, and we're looking for the collision shape 2D. There it is. And again, we've got a little alert because there's nothing assigned to it. It doesn't know what shape to use. So we go shape, and I think we're going to use a rectangle shape. 2 things to note. You've got an inner and an outer selectable area. You want to be manipulating the inner selectable area so that the blue region completely covers the character. Also, you'll notice that that shape is centered around the origin point, 0, 0, but the character is slightly offset. The animated sprite is not centered. This is easy to correct. We're going to click on the animated sprite, and you'll notice there's an offset entry, and I think we're going to reduce the Y value so that it does fit neatly within the box. Alright, so now we are ready to add a script. And scripts allow us to add functionality that isn't provided with just the built-in nodes. So you're going to click the player node and click the Add Script button. Okay, so the first line of every script is going to describe what kind of a node it's attached to. And in this case, we're talking about a script that's attached to an Area 2D. Then we're going to define our class variables. These are all of the variables that are going to be used in this node. using the export keyword on the speed variable is going to allow us to actually change the speed in the inspector, as well as let the inspector know what kind of data that variable should contain. This is really a lot of fun because it means that you can now change the specifics of any given variable in the inspector without diving deep into the code and manually changing all the numbers, which is really great for play balancing. This is handy for values that you want to be able to adjust the same way you would adjust any built-in property into a node. So we're going to click on the player node and set the speed property to 350. If you want the player to go faster, make that number higher. If you want them to go slower, make it lower. The variable velocity is going to carry our current movement speed and direction. The screen size is going to be used to set the boundaries of player movement so they don't go running off the screen. You'll notice that here we've manually set it to vector 2 480 by 720, the dimensions of our game. Next, we're going to use what's called the process function to define what the player will do. The process function is unique. It's called on every single frame of the game. So you'll use it to update elements of the game that are constantly refreshing. In our game, we need the player to do three things. We need to check for keyboard inputs, we need to move in the given direction, and we need to play the correct animation while we're moving in that direction. So first thing we're doing is we're going to check the inputs. For this game, we have 4 directional inputs to check, the 4 arrow keys. Input actions are defined in the project settings under the Input Map tab. In this tab, you can create custom events, assign different keys, mouse actions. You can have 52 different keys do 52 different things if you really want to. The default settings for UI left, UI right, UI up, and UI down are fine. They represent the arrow keys, so we're not going to change that. You can detect whether an input is pressed using the query of input.isActionPressed. It will return true if that key is held down and false if it's not held down. Combining the states of all 4 buttons will give you the resultant direction of movement. This means that it's not just checking for any one key at any one time. You can press multiple keys and get mixed actions. For example, if you hold right and down at the same time, the resulting velocity vector will be 1, 1. In this case, because we're adding a horizontal and vertical movement together, the player will actually move faster than if they just moved horizontally. This is physics, so you can prevent that by what we call normalizing the velocity, which means setting its length to 1 and then multiplying it by the desired speed. I'm just going to show you what that looks like. So we're going to do a new function, and we're going to call it getInput, and we'll start with stating that our velocity is equal to a 2-dimensional vector, and we're going to say, look, if the input action pressed is UI left, then we're going to increase the x coordinate of that decrease the x coordinate of that velocity by 1. Whereas if they are going to the right, we're going to increase the x coordinate of that velocity by 1. For up and down, we do the same thing: decrease the y by 1, increase the y by 1. Give me a second to just hammer that out. If input is action pressed, UI right, then velocity.x increases by 1. And you'll see that I say plus equals to increase something by 1 and minus equals to reduce something by 1. That's pretty common programming notation, and if you're a little thrown off by that, we'll do a little review of those kinds of operators in class. If input dot is action pressed UI down, Then we're going to increase our velocity.y by 1. That should work. Now we do what's called the normalization to prevent going diagonally to be faster than going left and right. And if you're a little confused by the physics of that, we can do a little physics lesson, but just trust me in that you definitely want to do this if you're doing a 2D game. If we are going to say if velocity.length is greater than 0, velocity equals velocity.normalized, which is a built-in command in Godot, times speed. Okay. God, I really hope this works. Should be good. Process is always going on. So what we're going to do is take that getInput subroutine or function, and we're going to stick it into process. So every frame, it's constantly looking for those inputs. It's going to be looking for those inputs like 40, 50 times a second. Has they pressed a button? Have they pressed a button? Have they pressed a button? Have they pressed a button? And if that button is pressed, then it's going to take that velocity data and translate it to the position of the player character. And that's what I've done here is I've put in position plus equals velocity times delta. Delta is the number of fractions of seconds that have gone by. And position.x has to be limited to the screen size of the of our game, and position.y has to be limited to the screen size of the game. So putting those clamps in place prevents the character from running off the screen. Let's check that out, see how it looks. And look at that, our character's moving right, moving left, moving up, looking down. I'm going to level with you, this character looks really tiny. I don't think I did a good job sizing it. But one of the great things about Godot is that's super easy to fix. So what we're going to do is go to Player, and we're going to go to Transform, Scale, and we're going to change the 1,1 to 3,3. And we've basically increased the size of this entire node by 300%. 300% on the x-axis, 300% on the y-axis, and if we move the character around, oh, that looks better. Look at you go, little guy. Right on. Alright, we've got a working player character, at least in terms of movement. Alright, so now our player can move. We need to change which animation the animated sprite is playing based on whether it's moving or standing still. The art for the run animation faces to the right, which means it should be flipped horizontally for movement to the left. We're going to cheat a little bit and use what's called the flip H property of a sprite. What we're going to do is add this to the end of the process function. We're going to, and we'll say if velocity.length is greater than 0, then the animated sprite dot animation. You'll notice I use a $sign in front of animated site. This is a relatively new thing in Godot. It just means point to that specific node called animated sprite. We're going to say animated sprite.animation equals run. Animated sprite.flip H equals velocity.x less than 0. Otherwise, animated sprite.animation equals idle. So this code takes a little shortcut. Flip H is a Boolean property, which means it can only be true or false. A Boolean value is also the result of a comparison, like less than 0, velocity x less than 0. So if it says animated sprite.flip H equals velocity x being less than 0, it's returning true or false. So we're going to add a new function for starting the game, and what we'll do is we'll set the player's starting position and starting animation. We're also going to do the def subroutine, and we'll say function die equals animated sprite dot animation equals hurt, and we'll set process to be false. And if you're wondering what I'm doing with this set process true, set process false stuff, all that does is deactivate or reactivate the process function which runs every single frame. If I set process to be false, the process function stops running altogether, and that way when the player dies, they can't still be moved around by pressing keys. So the player should detect when it hits a coin or an obstacle, but we haven't made them do that yet. That's okay, because we can use Godot's signal functionality to make it work. Signals are a way for nodes to send out messages that other nodes can detect and react to. You're going to want to write that down. Many nodes have built-in signals to alert you to all kinds of stuff, like when a button's pressed or when one body collides with another. But you can also define your own custom signals for your own purposes, and this is an incredibly powerful tool. Signals are used by connecting them to the node that you want to listen and respond to. This connection can be made in the inspector or in the code itself. We're going to add two signals. First one will be signal hurt, and the second one will be signal pickup, and we put them right where we define all of our other variables. Now check this out. We're going to go to the node itself. Yep, there he is. And we go to the node, and who did that? You did that. Good stuff. So now you've got those signals that you can just launch anytime you want. But for now, we're going to use one of the built-in signals. We want to talk about what happens when this player runs into something. So we're going to use area entered. So we're going to click on area entered. Connect. And we're going to connect this to our current script for the player. And you've got this new function now on player area entered, and it's referring to the area of the player. And what we're going to do is we're going to say if area dot is in group, and we're going to call the first group coins. Area dot pickup. And we're going to emit that signal that says pickup. Emit signal, and pickup should be one of the options now. Good stuff. If area dot is in group obstacles, emit signal hurt, and we also want to call the die subroutine that we've just built earlier. Functions, subroutines, exact same thing. It's the die function. So when another area 2D is detected, it will be passed into the function using the area variable. The coin object is going to have a pickup function that defines the coin's behavior when picked up. And when we create coins and obstacles, we're going to be assigning them to something called a group so that they can be detected as being, quote, coins or obstacles. So the next step is we got to make the coins. So we're going to start that right now. Brand new scene. We'll do another area 2D as the base for this scene. And just like before, we're going to add some children. We're going to add the animated sprite again, and we're going to add the collision shape again. And for the animated sprite, we're going to rename it coin. The area 2D will be renamed coin. And for the animated sprite, we're going to go frames, new sprite frames, and we're going to add a whole new animated sprite set, and this will be for the coin. So we're going to go to coin, there we go. And we don't need to name this one because there's only the one animation with the coin. And we can set the speed. We can make it flash as quickly or slowly as we want. We could say 12. And when we play, oh, I don't like that. It's going to give you epilepsy. Maybe we can slow it down a little bit. Yeah, it's a little better. Cool. Alright, so we have a shiny coin. Collision shape. We're going to use a circle shape because this is a perfect circle. And we expand that shape so it fills the whole sprite. Looking good. Now, we're going to transform this sprite because this sprite is absolutely huge. So we're going to make it half the size so it looks like it fits nicely in the working area of the game, which is 480 by 720. Yeah, I think half on the X and half on the Y axis is perfect. And again, that's under Transform Scale. Now we click on the coin, and we're going to click Groups. And as promised, we're going to define this as part of a new group that we're calling Coins. You go ahead and add that. And so now when it says, hey, is that area colliding with something that's called a coins, it knows that this definitely qualifies. We're going to create a new a new script just for the coin. Now here's the good news, is this script is going to be the easiest script ever. We need one function. We're going to call it pickup. And that is called by the player script. So the player script is going to say, hey, over there at the coin script, run pickup. And once pickup's happened, we're going to have it go queue free. And this is Godot's node removal method. It's going to safely remove that node from the node tree and delete it from memory along with any children that are associated with it. Save that scene, and now we're going to build the main scene. So again, new scene from scratch. We're going to add a node, just a generic node that does nothing. It's the little white circle, and we're going to call that main. And that's the base for everything. We're going to add some things to main. We're going to add a texture rectangle, and we're going to call that background. You're going to add a generic node just like main, and we're going to call that coin container. That's going to be really important. We're going to be magicking some stuff into coin container to make coins appear in a random way. We're going to add a position 2D, and we're going to call that player start. And that's going to mark the starting position of the player. And we're going to add a timer, and we're going to call that game timer. And that's going to track the time limit of the game. You want to make sure background is the first child node. Nodes are always drawn in the order shown. So whatever's at the very top is drawn at the very back. Whatever's at the very bottom is drawn in front of everything else. And we're going to add an image to the background node. We're going to use the grass.png image from the assets folder and put it into the texture property. Make sure you change the stretch mode to tile, and that should look pretty good. Something that I really like about Godot is you can instance a scene into another scene. So we're going to take that player scene that we built and we're going to stick it into the main scene as though it was a node. So now our player, which has its own properties and its own script and its own stuff going on, is inside our main scene, which will have its own properties and its own stuff going on. Okay, our main node needs a script, or I should say our main scene needs a script. What we're going to do is add, let's export a few more variables. We're going to export what's called a packed scene called coin. We're going to export an integer and call that playtime. And now those are both things that can be messed with from the inspector, which is very handy. We're going to add some variables: level, score, time left, screen size, and whether or not we're actually playing the game. And we want to make sure that they know that that's a Boolean, it's either true or false, so we'll set it as false to begin with. The coin and the playtime properties are now going to appear in the inspector when we click on main, and there they are. What we're going to do is we're going to add the coin scene that we created earlier to the inspector, and so now it knows that a packed scene stored in the variable coin is drawing from a scene that you've already created called coin. And for playtime, that's how many seconds of playtime the game will start with. We'll say 30. So now those variables have information stored in it. Coin means the scene coin. Playtime means 30 seconds. We're going to now do just the initialization part of the game. When the game starts, you want to initialize everything. So we're going to say under function ready, i.e. when the game starts, we want to hit randomize. We want to say the screen size is equal to the size of the screen, the viewport, the dimensions of that viewport, and the size of the dimensions of that viewport. I'll go into what this means more literally in a later class. And we're going to say the player node dot screen size is equal to screen size. Again, you'll see that the dollar sign in front of player. In the old days of Godot, you had to say get node bracket player dot screen size to refer to it, but with Godot 3, that get node command has been replaced with a simple dollar sign in front of it. It means if you want to refer to a node by name, put a dollar sign in front of it. And not putting that dollar sign in front of it means you're referring to a variable or an operation. Always the dollar sign if you're referring to a specific node. Think of that as like your noun command. Okay, we're going to do a new function for when a new game is started. We're going to show that we are now playing the game, so the playing Boolean turns true. Our level is going to start at 1. Our score is going to start at 0. Our time left will start at whatever play time has been set to in the main node inspector. Aha! We're going to call the player start function, and we're going to pass information to that function. You'll remember that in the player scene we had a function called start, and in brackets there's data that's coming in to that start. Well, this is data that's going out from here. We're going to show the player, we're going to start that game timer, and we're going to do a new subroutine called spawn coins, which means we better build that subroutine now. Spawn coins. We'll do a for loop, and we'll say for I in range 4 plus level. So it'll spawn more coins the higher your level is. Increase the challenge a little bit. we're going to define a new variable in the code and say C is called coin.instance. And it knows what coin is because it's that scene, that packed scene called coin that we defined earlier. Coin container, which is an empty node that previously did absolutely nothing, now is being told to add a child below it. That child is a new coin. So that coin container is now going to have a child automatically added to it, which is an instance of that coin that you made earlier. That child now has to have a location somewhere on the game. So we're going to say set its position to a random place between 0 and the X limit of the screen, so it can't spawn off screen. And set its Y position to be somewhere between 0 and the Y limit of the screen. So c.position equals vector2 with the X being equal to random range between 0 and screen size.x, and the Y being equal to a random range between 0 and screen size Y. Now, new game right now doesn't actually do anything because it's never called in the game. So we got to make sure that all of that stuff happens when the game first loads. So what we'll do is we'll go to function ready and we'll just call new game. So as soon as the game loads, the new game stuff is going to happen. And that's temporary. We'll eventually have the game start with a button press. We're going to save this main scene and we're going to run it. And you'll notice it's not running. There's a bug. So let's see what's happened here. It says invalid set index screen size on base area 2D. Now, when you're looking at bugs, you'll see here it tells you exactly where the problem was in your code. And here it says it's in main.gd at line 33. And because there is a problem at main.gd at line 33, it couldn't run main.gd line 27. And because there was a problem there, it couldn't run main.gd at line 17. So again, this is something that's great about Python, is it will help you diagnose exactly where your problems are. And not only that, but on the right, you can see all of the variables which are held at that moment of the bug. So you can see, maybe get a clue as to what might have gone wrong. So in my case, the issue is actually with the coin script. It doesn't know what screen size is. I forgot to declare that as a variable within the coin scene. So I've just done that, added screen size as a variable. And there we go, problem solved. And look at our guy. He's going around. He can collect the coins. As he hits the coins, they vanish. Looking good. Alright, moving on. So the main script needs to detect whether or not the player has picked up all of the coins and then start the next level. Since the coins are all children of coin container, you can use a check called getChildCount on this node to find out how many coins remain. You're going to put this in the process function, so it's going to be checked all the time, literally multiple times a second. So in function process, we say if playing, and that means the same as if playing equals true. If playing and coin container dot get child count is equal to 0. So if we're playing the game and there's no coins currently on the screen, then increase the level by 1, increase the time left by 5, and we're going to spawn some more coins. And you're going to spawn a few more than last time because the level went up by 1, and it spawns 4 coins plus the level. Alright. our game needs a user interface. I always like this part. So we're going to make a heads-up display. We're going to build a new scene. We'll use a canvas layer as the base, and we're going to rename it HUD. And the HUD is going to give us some information. It's going to tell us what the game's score is. It's going to tell us how much time is remaining in the game. It's going to give us messages like game over, you suck, whatever. And it's going to have a start button to just start the game. So under the HUD, we're going to put in some labels. We'll call the first label message label. And how are we going to do this? Let's do layout, center. And you see how I didn't have to like manually center it? You can just have it automatically centered through the layout structure. That's kind of handy. We're going to activate show helpers, and this will help you better align things to your grid in the game. We're going to, so what I've done is I've kind of stretched it out so that the label goes to the boundaries of the play area, and I've put in the words coin dash with a little exclamation mark. You'll notice that the default font, you know, even when we've centered it and aligned it vertically, it's not super pretty. So we're going to put in our own font, and you've got that too, so we're going to go font. We got to go new dynamic font, and you click on it, and then you have to load that resource. So under font, we go font data, we load, and it's under assets, I believe. Yeah, we're going to call it Kenny Bold. And you can't see anything yet, and there's a good reason for that. The font right now has a font size of 0. So we're going to go take the settings and give it a font size of 48 instead, and that looks much better. Good stuff. All right, coin dash. And I'm just going to fuss with it a little bit so I like its placement. Yeah, I guess that's fine. And what we can do is we're going to do a bunch more labels, and we can make our lives easier by just duplicating work or duplicating the properties of a label and assigning it to a completely different label. So what we'll do is we'll start by building a new label, and we'll call this one actually, better yet, we're going to take the parameters of the old label, of message label, apply it to the new label, and we'll call this label, score label. Alright, so now we have a score label and a message label, and we're going to duplicate the score label, and we'll call that time remaining or something. Let's call it time label. Good. So we have the score, we have the time remaining, we have a message. Score is going to start at 0. We'll shrink it and put it in the top left-hand corner. Time label is also going to start at 0, and we'll put that in maybe the top right corner. Alright, we're going to add a script to the heads-up display. We'll add a signal called start game, so that the game knows what to do when the game has started. And we'll add a new function, and we'll call it update score. We're going to have that function be containing a variable called value that's going to get passed around. So we're going to start by saying when the score is updated, the score label, text, is equal to the string of whatever value is passed to update score. And that'll be done from probably the main scene. So it'll eventually call update score value, and it'll just change that text to represent that value. We're going to do the same thing for the timer. As the timer is constantly updated, it sends a signal to the heads-up display that says, hey, update that number. We're also going to want a timer in the heads-up display, because we're going to eventually be showing messages, and we don't want those messages to stay forever. So we're going to keep the message up for 2 seconds, so we'll set the timer for a wait time of 2. And we'll say when that timer is timed out and that time is up, then that message that was sent can vanish now. We should probably also add a function to show the message in the first place. And we'll just say, pass information to the HUD that says show message, and when you say show message text, it says take that text and stick it into the message label, and then show the message label, and then start that timer. So it's going to take that text, stick it into the label, make that label appear, start a timer. That timer has 2 seconds. When the timer goes out, then that message will vanish. You'll notice I've changed the timer from the name timer to message timer, and I've disconnected, and I'm going to reconnect the node and just redo that. The reason why I've done that is if I want to add another timer later on down the line, I don't want 2 timers called timer. That's going to confuse the program. It's really important to name things what they are, and not get into any bad habits with giving things ambiguous names. You're going to save yourself a lot of grief later on. We're going to add a button that will just start the game. Let's not get too fancy. It's not going to be a real exciting button. There'll be no textures or anything. We'll just do a gray background button, and we'll just call it start button, and we'll put some text in it that says start. And of course the default text is real ugly, so we're going to put in our special font again. Don't forget, of course, to set the size. Let's do 30. That looks good. Alright, and that is our heads-up display. That button right now, when you press it, it's not going to do a thing. So we're going to have to connect to the script. So when the start button is pressed, what are we going to do? We're going to hide the start button to begin. We'll hide the message label because we don't want any text in our way when the game starts. And we're going to emit a signal that is start game, which you'll remember we defined earlier. And that should be it. We should also add another function that is played when the game ends. And basically when the game ends, we go show game over, and the message game over will appear in the message label. You'll remember the show message function is now being passed the words game over, And we're going to hold that message in place until the timer times out. And that's what yield means. When the timer times out, it then continues the rest of the code. Yield means stop here until this condition happens. And then once that condition happens, keep doing the rest of it. So it's going to go timeout, then it's going to go start button.show, message label.text equals coin dash, and then show that message label. We're going to save that scene. Alright, just like with the player, we're going to import the heads up display as an instance into the main scene. So we go main, make sure we're looking at the main scene. We're going to go import as an instance the heads up display. Oh, make sure you click main first. Yeah, and there it is. Boom. And so the heads up display has to be at the bottom. It's very important we keep that at the bottom, otherwise it'll end up buried behind everything else. And we never actually connected the game timer, so we're going to add the timeout connection to that game timer. And when the game timer times out, which is, I believe, every second, the time left drops down by 1. The heads-up display now has to show that the time left has dropped by 1. So we do that update. We call that update. You remember we made that update in the heads-up display script where it says, here we go, update timer value. So it's taking that value, in this case that's the time left integer, and updating that text on the screen. If time left is less than or equal to 0, then we call the subroutine, the function known as game over. And we've set the wait time for 1. So this is happening every second. Every second the time left is dropping by 1. The update timer is updating that dropping by 1, and it's checking to see if you hit 0 time so that it can run the game over screen. Okay, you'll recall that in the player we built the signals pick up and hurt. They don't actually do anything yet because we haven't connected those signals. So we're going to say what happens when a player picks something up. Well, the player's score is going to go up by 1, and then we got to update the score in the heads-up display, just like with the timer. And what happens when the player gets hurt? Right now there's no way for the player to get hurt, but eventually there will be. And when the player gets hurt, we'll say that we're going to call game over in main. So when the player gets hurt, we're going to call a brand new function, and we're going to call that one game over. And in main, we're going to get started building that game over function. Several things need to happen when the game ends. We need playing, that variable playing, to equal false. We need the game timer to stop. We need all of those coins that we created to vanish. So we do a for loop and say for coin in the number of children in coin container, make them all queue free, make them all vanish. Then the heads up display, of course, needs to be updated to show game over, and the player needs to die. And I believe that'll play the die animation. So this function will halt the game. It'll loop through the coins, remove any that are remaining. It'll call the heads-up display's show game over function. Now, right now, the new game function starts right when the game loads. We don't want that. We want it to start when the button that says Start Game is pressed. So we're going to go to the HUD node, and we're going to see that that signal that we created, Start Game, we're going to connect that. But we're going to do a little something different with this one. We're not going to turn it into a new function. We're going to connect it to a function that we know already exists. So what we're going to do is click Make Function to Off. And the node that we know already exists is New Game. Sorry, the function that we know already exists is called New Game. So now it's just going to call New Game when that signal is triggered. So we know the Start button is pressed. It signals Start Game, which connects over to New Game, and then it does all that New Game stuff that we've defined earlier. If that was a little confusing, I apologize. We can go over it again in class. Couple things to clean up. One, we're going to take New Game out of the Ready function, because now New Game triggers when you press the Start button rather than immediately when the game is run. So we'll just get rid of that. And the other thing is we want the heads-up display to update the score and the timer when the new game is run. Cool, we run our game. And looking good. Collecting coins, time's running out. Alright, I'm going to show you guys a few tricks to make the game look a little bit more exciting. We're going to start by adding a tween node to the coin scene. A tween is a way to interpolate a value over time. I think I'll probably spend more time later on explaining what I mean by this. But how it works is, instead of just doing an animation, you can do an animation using software. It actually will use code to figure out what you are looking to happen, rather than having you manually animate every little thing. For example, we can assign a tween to alter one or more properties of a node. In this case, what we're going to do is we're going to increase the scale of the coin and also cause it to fade out as it gets bigger. So that coin's going to expand outwards and fade to nothingness as it's picked up. Okay, so you're going to add this line to the ready function of coin. Tween.interpolate property, we set the object as being the animated sprite of the coin. We're changing its scale. We're doing the start value of animated sprite dot its current scale. We're then going to take its current scale and set the endpoint to being 3 times that. So it's going to go 3 times as big as it was initially. It's going to do that in 0.3 of a second. And the way it transitions is going to be called transquad and an ease in or out. These are actually terms used in filmography And maybe I'll do like a little micro lesson in film editing and filmography, but basically this is the way that the camera is moving. So the interpolate property always has 7 parameters. What node is affected, what property is altered, what the property's starting value is, what the property's ending value is, the time it takes to get from start to finish, the function to use, and the direction it's going. This tween will start playing as soon as the coin is picked up. So what we're going to do is get rid of QFree in the pickup function and instead call the tween. We're going to set monitoring to false, and that ensures that the area enter signal is not going to be emitted if the player touches the coin while the tween animation is occurring. So as the coin is expanding outwards, it's not going hit player, hit player, hit player, hit player, hit player. That's a very common mistake people make. So you got to make sure when you pick it up, the monitoring of the status of the area 2D is set to false temporarily. Then you start the tween. Finally, when the animation is finished, you also want the coin to be deleted. So we're going to set a function that says on tween, tween completed. Then we go QFree. So you hit the coin. The sensitivity of the area 2D is disconnected. It runs the tween animation, and then it destroys the coin when it's done. Alright, we're gonna check it out, see how it looks. And he goes, and you'll see now the coins now expand outward before they disappear. Looking good. Get those fat stacks. So next thing we're going to do is let's fade the coin out as the coin is growing larger. So we do another tween. At the same time, it's going to look more or less the same, only this time we're changing the modulate property. And we start with the before, and the before, its color is normal, 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 normal. And I'll talk about how color parameters are handled in Godot on another day. It's kind of annoying. The after is the color is normal red, normal green, normal blue, but the transparency is set, or the visibility I should say, is set to 0. It is fully transparent. So now it's going to tween from completely normal to completely invisible. And it's going to do all the little frames in between over that 0.3 of a second. And that's all there is to it. We run it, and it's going to look a lot nicer. Okay, tweens are good. Sound is better. Sound has been made a whole lot easier in Godot 3. What we're going to do is add some audio stream players to main. Sound's one of the most important but often neglected pieces of game design. Good sound design can really add a whole lot of polish to a game with minimal effort. Sounds give the player feedback, it connects them emotionally to the characters, it can even be a gameplay mechanic. We're going to create 3 sounds to start. We're going to do a coin sound, a level sound, and an end sound. And each of those sounds we're going to connect through the stream to sounds that I've pre-generated for you. We have a level sound, a coin sound, and the end sound will be hit.wave. Now to play a sound, all you got to do is call the play function on it. So what we'll do is we'll go to the player pickup function and add coinsound.play. We'll add endsound.play to the game over function, and we'll add levelsound.play to the spawn coins function. And that should really make a huge difference. So there's lots of opportunities in a game like this for objects that give the player a small advantage or a power-up. So we're going to add a power-up item that gives the player a small time bonus when it's collected. It's going to appear occasionally for a short time and then disappear. It's a window of opportunity kind of mechanic. So we're going to build a new scene. It's going to be very similar to how coins work. So why don't we cheat a little bit, take the coin scene, and save another copy of it. We're going to go to the coin scene, go save scene as, and then save it as something new called powerup.tscn. We're going to change the name of the root node to powerup instead of coin, and we're going to remove the old script by clicking clear script. Don't forget that in the Groups tab, you're going to remove the Coins group by clicking the Delete button and add it to a brand new group called Power-Ups instead. Very important. In the animated sprite, we're going to change the image from the coin to the Power-Up image, which I gave you. It's in the assets/POW folder. Okay, you're going to add a new script to powerup.gd, and then you're going to take the coin script and copy that, paste it in powerup.gd, and then you're going to change the oh, you know what, come to think of it, there's nothing in there that needs to be changed because the coin scene is not referred to by name, so you should be good with just that. Can you tell I'm getting tired? All right. Okay, in player.gd, we've referred to a bunch of things the player can interact with. So we say if player is in group coins, area.pickup, emit signal. If area is in group obstacles, you're hurt and die. You'll notice we haven't actually built any obstacles yet. That'll be later. We're going to add a new thing, and that's going to be if player encounters power-ups. Now, the first thing we got to do is we got to make sure the power-up has a timer. And we're going to call that timer lifetime. And this makes sure that the power-up is temporary. And we're going to say when the power-up has timed out, it needs to vanish. So we queue free it. We're going to have to go back to main, and we'll have to add another timer there to generate the power-up. We don't want just the power-up happening any old time. So we'll have a power-up timer. We could set the wait time to, well, you know what? Let's have the power-up show up randomly. So we'll leave the wait time. We'll set it to one shot being on. And we'll say when the power-up timer is done and it's timed out, then generate a power-up. We'll put in another audio for the power-up sound. We'll call that the power-up sound right there. And we'll say, yeah, when the power-up timer is timed out, we'll do the same thing we do with coins. We'll say variable p is equal to a power-up being instanced, being generated. And we'll add that as a child to main instead of a child to coin container. It shouldn't really matter, but I think it'll be fine. So we'll add that as a child to main, this power-up instance, and we will set its screen size limitations as being the same as the parameters for the coin. In fact, we can just copy and paste the same code. P.position instead of C.position because we're using a different variable now. P.position is a random location between 0 and the x-axis limit and 0 and the y-axis limit. And of course, it doesn't know what it is yet, so we got to build another pack scene the exact same way we did the coin, and we'll call that power up. And that should work. Don't forget, of course, to add that scene to the inspector. So how much time are we going to give the player to pick up the power-up? Let's say we'll set a timer with a wait time of 2 seconds. It's a one-time timer, so we're going to hit one shot being on, and auto start will be on. And we'll run that. And you'll notice nothing's happening. Power-up hasn't shown up yet. Can you figure out why? We never started the generate power-up timer at the very beginning. Ah, now we haven't even started the game yet, and it started within 1 second. So we auto-started the power-up timer. We gave it a wait time of 1 second. But we don't really want to do that. We don't want to start the game with that timer on. We want the timer to come on when the game has begun. So what we're going to do is start that timer in the game. And we're going to put it at spawn coins. So as soon as it spawns coins, it's going to activate the power-up timer. And 1 second after, it will spawn a level-up token. But instead, why don't we change that wait time to be something random? So after coins are spawned, between 5 and 10 seconds later, it'll make a power-up show up. And that power-up will stay for only 2 seconds and then vanish. And you have 2 seconds to grab that power-up. So we got to go back to the player area entered. And we got to make sure that the pickup is called when you collide with the power-up. And you emit a new signal, and that new signal we'll call pickup power-up. You'll notice that we've now got 2 properties that are being emitted. We're saying emit a signal called pickup and make sure that the information of power-up is transmitted with that signal. I'm going to show you what this looks like and why this is kind of cool next. You'll see that in the main, under on-player pickup, we can now pass information over to it. And we're going to pass this new thing called type. So now that we're emitting the pickup signal with an additional argument that names the type of object, the corresponding function in main.gd can be changed to accept that argument and use the match statement to decide what action to take. The match statement is a useful alternative to if statements, especially if you have a large number of possible values to test. I'm going to be honest with you, I always forget that match is a thing that exists and regret it because it makes life so much easier. So if I can pass that on to you, I hope you remember it. It'll make your code look a lot cleaner. So we are right now matching type against coin or against power up. If it's coin, we play the coin sound, score goes up by 1, and we update the GUI, the heads up display. If it matches to power up, the time goes up by 5. And we play a different sound and all that. And our character's walking around, nothing's happening. Not entirely sure why. Oh wait, I know why. Do you know why? What's missing? What's the one thing we've forgotten to do? We got to go back to player. You see how we emitted the signal pick up power up? Well, we also have to emit the signal pick up coin. So we're picking up coins. And there's our power up. So when we created the coin scene, we added an animated sprite. It's actually not playing yet, you may have noticed. The coin animation displays a shimmer that travels across the face of the coin. If all the coins show this at the same time, it's going to look really regular. It's just not going to look very professional. So you want every coin to have a small random delay in its animation. This is really easy to do. First, we're going to click on the animated sprite, and then on the frames resource. We're going to make sure that loop is set to off. And do we want to keep it at speed 8? Yes. And then what we're going to do to the coin is we're going to add a timer. And add this code to ready. We're going to say timer's wait time is random, and it's going to be randomly set between 3 and, let's say, 8. And then we're going to start that timer. So between 3 and 8 seconds, it'll start ticking down a timer. And the timer will be like 1 second, not a big deal. And then when the timer times out, it then starts the animation. It'll start at frame 0, and it'll play. And so if you run the game, you'll watch for the coins to animate. It's a really nice visual effect for a very small amount of effort. And you're going to notice a lot of little things like this in professional games. They're subtle, but they make for a much more pleasing experience. You can do the same thing to the power-up object, but I'm just not going to do that. Okay, so the game needs to be made a little bit more challenging by introducing an obstacle that the player has to avoid, other than just running out of time. Touching the obstacle is going to end the game. So there's all kinds of ways you can do this. We can have the obstacles change position as the levels go up, or have more obstacles show up. You get how that works now in concept, so we're just going to do a single fixed obstacle on a fixed point in the map. And if you want to get creative, you can do that on your own time. We're going to create a new scene for a cactus, and we're going to add the following nodes. We're going to have an area 2D. That'll be our base, and we'll call that cactus. We'll have a sprite as a child. Not an animated sprite, but just a regular old sprite. It's just a static image. And a collision shape 2D. Alright, I'm gonna level with you. That cactus is way too big. Way too big. So what we're gonna do is we're gonna experiment a little bit and see if we can get a size that feels good for a game with the screen dimensions of 480 by 720. Let's scale it down. Let's do 0.3, 30%. Still a little big. Let's do 15%. Well, how about halfway in between? Let's do 20%. There you go. That'll work. I like it. Okay, do a collision shape 2D. We'll do rectangle for this one. And we stretch it. Just like before, you'll notice that it's a little bit offset, so we got to do the same thing. We go offset, and we'll go negative, let's try -5. Not enough. Try -15. A little more. Actually, I'll be fine. Okay. And we're going to change the rectangle so it fills most of the cactus. That's good. That's good. All right. So we have a cactus, we have a collision shape that goes with the cactus. We need to describe that cactus. So we're going to go groups. And make sure you're clicking on the cactus itself, not the collision shape 2D. The cactus, groups, and we're going to call the cactus obstacles. And add that. Good stuff. What we'll do is we'll instance that cactus into the main scene. Oh, forgot to save it. You gotta save your scenes before you can instance them. Cactus is now its own scene. And we'll instance it now in the main scene. And we can move it into any location we really want. And we can play the game and see what happens when our character runs into the cactus. Oh, okay, good. So the cactus works. We already did all the legwork. We just needed to put in an obstacle. And you can put in all kinds of different obstacles using the same code. Like, this part of the joy of the modularity of this is you've already established what an obstacle is, and now the character knows how to behave when it encounters it. But you may have spotted a problem. Coins, right now, the way the game is coded, can spawn behind the cactus, and that makes them impossible to pick up, and it's impossible to advance in the game. So this is very important from a game design perspective. When the coin is placed, it needs to immediately detect if it's overlapping an obstacle. So what we're going to do is go to the coin's area entered signal and add the following. We're going to say if area dot isInGroup obstacles, we're going to reposition it. We're going to say its position is vector2 somewhere randomly between 0 and the x-axis limit, and somewhere between 0 and the y-axis limit. And you may be saying, well, Professor Hewer, what happens if it repositions itself randomly back behind the cactus again? And the answer is, then it will run coin.areaEntered again, and it will reposition itself again. And it's going to keep randomly repositioning itself, the coin, until it finds a spot that's not sharing space with the cactus. How about that? And that, ladies and gentlemen, is a complete game from scratch in less than 2 hours. Get proud. Most people don't make it this far. You used signals to share information between scenes. You learned how to procedurally generate instanced nodes. You learned how to interpolate frames. And most importantly, you learned what all that technobabble just meant. There was a lot to unpack in this activity, and sadly it is going to get harder. But I hope you're satisfied with your results so far, and we're going to do some more practice in class. For now, let's play you out to something inappropriate.